Hey, what's up, Patrol Pal, Mr. Cook? We're doing the Unit 7 test review. We've got through the 7.1 material, the 7.2 material, and the 7.3 material. Now we're on to 7.4. 7.4 is your section that's going to be on family of functions. So this is a pretty easy process. When we get to the graphs, it's like, I don't think it's super challenging or anything like that, but you need to remember where different parts of the transformations take place for these, functions. Any function that you have, f of x, can be affected by different transformations, any multiplication or addition that happens inside the function or outside the function. So like if you have a number that's multiplying on the x value, or it could be multiplying on the function itself, like on the absolute value or on the square root or whatever. You could have numbers that are adding or subtracting inside the parentheses of the function, or you could have values adding or subtracting outside the function. All of those things change how the function itself behaves, how it graphs, and the different properties of it. From some original function that you have. The original functions that we deal with in class the most, so the ones that you want to memorize the most, are like the quadratic functions. So whenever you have some input and you square it. Another one that you have is the cubic functions. So that's when you have an input and you raise it to the third power. And then conversely, like, if you want to solve them, then you have the square root functions, the cube root functions as well. And then a couple other ones like the absolute value function. And we're not really going to talk about trig, so probably just the absolute value functions. Those would be the ones you'd want to know the most, right? And just how they look, square, square root, cube root, absolute value. And so here, I'll show you like how a lot of this stuff translates with this function over here, with this kind of functions transformation stuff. If you multiply a number out in front of any of these, like the a value here, what a does is it tells you that you're either going to have a vertical stretch or a vertical compression, and that all depends on what the number is that you're multiplying out front. A vertical stretch occurs when your number that you're multiplying out in front of the function is greater than 1. A vertical compression happens when that number is less than 1, so greater than 1, less than 1. And then if that a value is negative, then you have a reflection, and the reflection will take place over the x-axis. So that's how I like to write out reflection over the x-axis instead of writing everything down. What the b value does is something similar. We don't typically use the b value a lot except for one little transformation, and that's if it's negative. If it's negative, then that means you have a reflection over the y-axis instead of the x-axis. So that's the only one you really need to memorize for like when it's multiplying on the x value. If you have any addition or subtraction inside the parentheses, that's the c value, and that moves the graph to the left or to the right. So the graph will move to the left if the number that you have in there is adding on, and it'll move to the right if that number is subtracting onto the x value. And then the last thing we have is this d value here, and the d value moves the graph either up or down. It's easy to remember that one because d, the last letter that you'd have, d here, would be like down, like the word down, d for down. I don't know. Just trying to throw it out there. If you want to memorize it, you can. But moving the graph up means that you're going to be adding a number on at the end outside the parentheses, and moving a graph down means that you're going to be subtracting a number outside the parentheses. So let's see how all this stuff kind of translates back over to here, okay? So check it out. It's actually pretty easy if you just know what the various letters mean. So it says we start off with an absolute value function. So that's this. This is what we're using right now for number 15. So absolute value of x equals y. So here's how we write it out first. Then it says that the absolute value function is shifted 2 units to the right. So if it moves the graph to the right, that means that we're subtracting inside the parentheses. So we're subtracting by, 2 units to the right, so minus 2 inside the parentheses. And we know that it's inside the parentheses because c is inside the parentheses there. The next thing that we have is that the whole graph or the whole function, absolute value, gets moved up 5 units. So if it's moved up 5 units, that's up right here, so that's the d value, so we're adding or subtracting, and since it's moving up, that's adding, so plus 5. And then it's reflected over the x-axis, so that's the last of the transformations that we have here. If it's reflected over the x-axis, that's a negative that's in front of the function. So if the function is absolute value, we have a negative in front of that. That's constructing an equation based off of the transformations. That's exactly what it's asking us to do on number 15. Number 16 is the cube function, so we set it up very similarly, y equals, and give it some space. It's going to be x, and then raised to the third power, cubed. That's why it's a cube function there. All right, so if it's shifted 2 units to the right, that's one transformation I need to do. So let's see, moves to the right, so that's the c value, so that means it's adding or subtracting. In this case, since it moves to the right, it's subtracting, so minus 2 in the parentheses. And then it says 3 units down. So up and down is adding or subtracting outside the function. And since it's moving down, it's subtracting, so minus 3. Those are the only 2 transformations that we have to worry about, so that's the function completely put together. All right, so that's number 15 and number 16. Those are the equations that we work with. But we're going to use this an awful lot on the next page when we're graphing, when we're pointing out the transformations that we have. So keep that stuff in mind. And maybe copy it down if you get a chance, so then you have it available for the next page. Because I'm going to use it basically as if we're reciting it from memory. All right, so we're going to sketch the graph of each equation by starting with the graph of the basic function and show that as a dotted line. So again, the ones that we're going to be graphing out are x squared, and x squared looks like this. It starts at the origin, and then it's like a little U shape. That's how it usually looks. Then we also have x to the third power. That one has the origin in the middle, and then it goes up on one side curved and then down on one side curved like that. Another one that we have is the square root function, and that one looks like this. It starts at the origin, and then it's kind of like half of a parabola going up and to the right, like that. So it's kind of like curved and slowing down as it's moving forward. All right, and then we have the cube root of x. That one again starts at the origin, and then it's kind of like a sideways S, so it like goes this way, and then it goes down and this way to the left. And then the other one that we have is, again, the absolute value. And the absolute value looks like a V shape. Starts at the origin, and then it just goes up to the right and up to the left like that. And it should be like pretty symmetric over the y-axis when you graph it out. And by the way, if you have a graphing calculator, you can graph out every single one of these really, really easily. So, there's always that too. It says to graph each of the starting functions, so I'm going to start by just graphing those with a dotted line. So this one has the absolute value. So the absolute value just starts at the origin, and then it's a dotted line that goes right down the middle, up and to the right. There's my absolute value, and then also right down the middle, up and to the left. Like that, there's my absolute value, that V shape that I was talking about. This one has the square root. So the square root starts at the origin, and then it goes through 1, 1, and then 4, 2, and then 9, 3, so it's like a little bit further off from there. So it just looks like this. And then we have the square function. The square function, again, just starts at the origin, and then it's like a parabola. So it goes to 1, 1, and then negative 1, 1, 2, 4, negative 2, 4, and then 3, 9. But that one's off the graph, so we're just going to graph it out like this. There's a little U shape, our parabola. And then our cube root, so it looks like there's a negative on it. So we got to take note of all this stuff a little bit later. But cube root starts at 0, 0. It goes through 1, 1. And then it goes through 8, 2. And then this one's going to go negative 1, negative 1. And then negative 8, negative 2, like that. So here's the little S shape that I was talking about that it makes. There we go. All right, now let's list off the transformations. So using the techniques of shifting, stretching, and or reflecting, and state all the transformations. Oh wait, I should have made all these dotted lines, dang it. All right, so I'll make little dotted lines, I guess, real quick. Just erase parts of these. That's my bad. Didn't follow instructions. There we go, those kind of look like dotted lines, I guess. Oh well, they'll have to do. All right, here we go. So those are all our little dotted line stuff, whatever. Now, the transformations. So I have a 2 multiplying out front, so that's going to be a vertical stretch. I have a +4 inside the parentheses, so that's a left 4. I have a -4 outside the parentheses, so that's going to be a down 4. Now let's go to the other ones. So remember, it's just about like where you're adding or subtracting that tells you if it's moving left or right. If it's inside the function, like inside the square root, that means it's going to move left or right. So this tells me I'm going to move to the right by 3. And then I have a -4 outside the parentheses or outside the function, so that's up or down, so this moves down by 4. So those are the only two transformations for that one. For number 19, I have a -3 inside the parentheses, so that's right 3. And then I have a +2 outside the parentheses, so that's up 2. For this one, I have a +3 inside the parentheses, so that's going to move the graph to the left 3. And then this -5 outside the parentheses, so that moves the whole graph down 5. And then I have a little negative out front as well, so that means that I'm going to have a reflection over the x-axis. And I'll show you how all that stuff looks in a little bit. Okay, so I don't know how accurate your teachers want you to do these graphs, but I don't think that they need to be like works of art. They don't need to be Rembrandts, they can be Picassos, so they can look a little bit weird if you need them to. But typically, like, always start with the origin and move it with your left or rights or up or downs, okay? So, like, gives you a point of reference, and then just kind of go from there. So this one says that we're going to move the whole graph to the left 4, so 1, 2, 3, 4, and then down 4, 1, 2, 3, 4. So that's a new starting point for the graph, and you can do that with all these. Like, you know, it always starts at the origin, so this one moves to the right 3, 1, 2, 3, and then down 4, 1, 2, 3, 4. This one starts at the origin, and then it moves to the right 3, 1, 2, 3, and then up 2, 1, 2. This one starts at the origin in the middle, and we're going to move to the left 3, 1, 2, 3, and then down 5, 1, 2, 3, 4, 5. And then this is when we can start graphing out all the rest of this stuff. This has a vertical stretch of 2, so that means that instead of going up 1 over 1, it's going to go up 2 over 1. So up 2 over 1, 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 and then up 2 left 1 as well to make that little V shape. So this is how the rest of our graph looks. If you have one of those nice graphing calculators, let me show you what you can do with this real quick, just to expedite the graphing process. So what you can do is just type in the whole graph itself, you know, the whole expression, so like y equals 2, and then absolute value might be the only one that's a little bit weird to find on your graphing calculator, but you can find it by hitting the math button and then going over to number and then absolute value, and then you just type it in, x plus 4, and then minus 4 outside the parentheses, and then you can just go right over to your table and start graphing some points. See, check it out, 0, 4, just like the one that I have there, and then 1, 6, just like that one, and I can go backwards, -1, 2, so -1, 2, and then I can get -2, 0. See, like, you can graph all these points out on your graph if you have a graphing calculator, and that, by the way, is going to be the same for all of these. You know, you can just type it in and graph it out using the table option. So, and you know, use that however you need. For the rest of this, however, it's not terribly difficult. You just have a lot to remember for it. With a square root function, this one goes up 1 over 1, and then over 4, 1, 2, 3, 4, up 2. So there's the rest of our little graph. So that's number 18. Number 19, so we have this parabola, and it's moving to the right, and then up 2, and then it's just a regular parabola, so up 1 over 1, and then over 2, up 4, 1, 2, 3, 4. And then reflect it, so 2, and then 1, 2, 3, 4. And there's our parabola when it's all done. And then the last one, this one's the real crazy one, where you have to reflect it and then also move it, so it's like reflected over the line. So this one usually goes, let's see here, left 1, down 1, so now it's going to be reflected, so it's up there, and that one's down there. And this goes over 8, 1, 2, 3, 4, 5, 6, 7, 8, and then down 2. And And then the other one's going to be like way off the graph, so it's not going to work. So there's our little S shape. It's a weird one, huh? Gosh, I hope we don't have one like that on the test. That one's not that bad, though. But, you know, still, I don't want that many transformations. Anywho, so that's all the stuff for 7.4, including the graphs. My goodness. And if you need a little bit more work on your graphs, you know, just check out the stuff in 7.4. And, you know, talk to your teacher. Make sure that you know the level of detail that you need. The ones that I have right here are extremely detailed. And I happen to know that, like, some of the teachers kind of only want you to kind of just get an idea of what the functions look like. Other ones want you to make sure that you have everything, like, specific. So make sure that you reach out to your teacher. Okay, that's it for this video. This one ran a little bit long, but luckily we only have, it looks like, 2 more problems. One of them is a doozy with the word problem, but it's not that bad. Okay, that's it for this video. On to the next one.